Oh, there it goes. I think it's recording. I'm not sure though. I hope so, otherwise I'm going to have it on and it's not going to record. All right, the reason it's kind of good timing is with the coronavirus because it's super applicable with this. Somebody actually just fit a math model to its growth, and what they do is they chart the rate that it's changing, and when you do that, that's called a differential equation. We've been working with them almost exclusively with dy dx, and that's how y is changing over time. When we solve a separable differential equation, it means what is y, but that's the math of it. So we eventually want to go to what actually is changing, which is time. So you're eventually going to have things changing over time, and you're going to be charting their change. Like it might be the rate that the population is growing over time, or it might be the rate that bacteria in a dish is growing over time. And if it grows at a certain rate, then you're positive for strep or something like that. It might be the rate that the coronavirus is spreading every week, where T is in weeks. And so we have this rate of change, and when we solve it, or solve a differential equation, what you're looking for on this one would be what is y as a function of x? What's the population 8 years from now as a function of time? How much bacteria is there in 30 minutes? That's actually why you have to sit and wait when you get a strep test. They're waiting to see if that bacteria is growing fast enough. How many people will have the virus if it grows at this rate in 7 or 8 weeks? Do you see how it's pretty applicable? We don't get to it as well in here as how it is currently being applied to the coronavirus because it's a logistics growth, and that's Calc 2. Do you guys know what logistics growth is? It's when it starts off exponential, but then what happens? Then it tapers off because most people have it or they've started to eradicate it. This point right here on the graph is really important for scientists and medical personnel and stuff and dealing with infectious diseases right here because this is where it is growing the fastest. Do you see how the slope of the tangent line right there is the greatest? But it's also with calculus the change in concavity. So guess what it is right there? An inflection point. Yeah, so we learn in Calc 2 how to actually find where it's growing the most rapidly. For you guys, we're just going to start off today. It's all going to be dy dx, and we're just going to figure out, well, how do you solve them? And you can solve with a method called separation of variables, but there's so much more to it. That's the only method you're going to learn this year. The rest of it comes in a whole nother course. Are you ready? So it has to be able to be written like this. F is some function of y as y changes, and some other as a function of x as x changes. And this doesn't make sense right now until we actually go do it, but the most important thing to notice is right here, these are products. So you have to be able to write it somehow, if not given, as products. Right? So I'll show you what I mean by that. You guys look sleepy today. Every time I put the headphones on, we get sleepy. All right. So down here, I've got two equations. This one is considered separable. So this can be done with methods of Calc 1. If you can't separate it, it's got to be like Calc 4. All right, so let's go take a look. If I want to separate it, it means I want the dy on this side, and then I want to move the y over. How would I mathematically move that y over? Divide by it, yeah. So if you can write it as, this is what I meant when I wrote f of y dy. It's a function of y times change in y. And over here, I'll keep the x, correct? And then how would I move the dx over? Multiply. So this has been separated. If you can separate, you can solve with methods of Calc 1. If you can't separate, what did I say? It's too hard for us right now. It's a whole nother class. It's a semester course in college. All right, but if we can separate, we can solve in here. So down here, this one right here is called a non-separable differential equation. The only way I can move that y over is to subtract it. I can't write it as a product, correct? But if I just tack an x on here, go ahead. So this right here, let's go on the side and rewrite it. So go write it over here and make it x plus xy. So it doesn't mean every time you see addition, you can't separate. But for this guy, what I would need to do if I wanted to separate it is write it as x times 1 plus y. Then how would I separate it? Now I could. What would I divide by, Miles? Yeah, I divide by a 1 plus y on the left. And so I would separate the y terms over on the left by doing the opposite operation, and then I get all the x terms over on the right. It is now separated. So a lot of kids will get one like, let's do this. Write this right below here. Actually, I think this is coming up on a quiz, so I would tune in. I think it's an e to the x plus y or an e to the x minus y. I can't remember, but some people look at that and say, oh, LaRude, you said we can't separate it if it's a sum. Right now, it can't be separated. But do you know how I can rewrite that guy? What'd you say? No, no, Ellen, I just want to separate it. Because I can't natural log a derivative. There it is. Yeah, so sometimes you have to, your gut instinct might say it's not separable, but keep in mind, you aren't going to be asked to solve it if you can't separate it. That wouldn't be fair, right? So Ollie just had to kind of think about it. Well, how could I rewrite it? Do you agree those are the same? And now I can separate it. I could divide the left by e to the y, right? So, and we'll talk about what you do after you separate it. I just want to make sure you understand what I mean by separation of variables. A function of y dy, a function of x dx. Does that make sense? All right, so let's go take that first one up there, and we're going to actually go solve it. So it says if it's separable, what you do is you take the antiderivative of both sides. So on this one, I'm going to be solving it for y. When I'm all done, I want y equals. So let's go write our answer over here, y equals. So the first thing I'm going to do is get everything in terms of y on the left. So I will do 1 over y dy. And then on the right, I'll leave x dx. That's how it starts. If you don't separate correctly, you'll never get that back again. So I'm going to go write separate. Am I going too fast, Rachel, or are we good? All right. So then what we're going, sometimes when this is my third time doing it, I feel like I go a little too fast. So let's go right here. The next thing you're going to do is integrate. And you'll know how to. It'll be some method. Today I won't throw any u sub at you or anything. We'll just do regular old. It'll be pretty normal integration. Sometimes you have to be clever though, but not here. All right, so I'm integrating both sides. It will be easy to find the antiderivative today because that's not the point of this. It's more the process. So Paige, what's the antiderivative of 1 over y? Somebody help her. Natural log of absolute value, which is going to be important, so make sure you put that on there. Technically, there's a plus c, correct? We're going to leave it off, though, okay? On this side, the antiderivative is x squared over 2. Both of them technically have a plus c, but what you're going to do is put it all over on the right, because a constant minus any constant is still a constant. So it's good just to consolidate all your constants over on the right-hand side. So the first thing you do, separate, right? Then you integrate. Now you'll be on the y attack. So how do I undo natural log? E. Yeah, it's called exponentiating. So you're going to take each side and raise it to the power of e. So let's go ahead and write that. And this side we're going to be clever with. So you're going to go ahead, put that c up in the exponent. I'm going to erase that right there so it looks a little better. All right. So the next thing you're going to do on the right-hand side is what Alejandro told me to do with that last one. This is a super common move right here, by the way. You're going to take this and write it as e to the x squared over 2 times e to the c. Sam, do you believe that those are the same thing from here to here? Yes. Now, what is e to any constant? A constant. So now how it depends on, what professor you have, what book you're using, what college you go to, who your teacher is, how they want you to deal with the constants. I'm in the middle of the road. So if I was super picky, I would have said, Rachel, you need to put a plus C1 on here, a plus C2 on here. Tell me C3 is C2 minus C1, and then call this C3. But I'm fine with you just making it another constant. Same with how you deal with this. Some books will say, ooh, we better call it K or whatever. I'm fine with you just calling it another constant. It works out the same mathematically. All right, so it's just some other constant. So let's go on here and write e to the natural log of y would be natural log of y. I'm sorry, just the y. And then this would equal. This became a whole other constant. How are we doing? What do you think, Devin? You good? All right, so Devin, if I said the absolute value of y is 5, what would you tell me y equals? Or -5, correct? So what we're going to go down here is say y is equal to, for now, plus or minus c e to the x squared over 2. Here's my question for you. What's plus or minus any constant? What do you think? A constant. So it's totally acceptable in this one for you just to say, well, this is some constant times e to the x squared over 2. Now, if you were to go graph on your graphing calculator, which I did first hour, go put this in. This is called the solution to the differential equation. What's it called? What is it? It's the solution. It differs, though. There's a whole, you don't have to put it on your calculator. I'm going to tell you, I already did. What it looks like is this. This is when C is 1. Actually, should have gone through 1. But then when it's 2, it goes through 0, 2. When it's 3, it goes through 0, 3. And they all differ by this constant. But do you see how the slopes at all these, like say x equals 1 is the same for all of those red lines, right? So it gives me the whole family of functions whose derivative here, 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 an infinite amount of places is the original. So what do you think I have to do to get you to be specifically on this curve? Give you a what? A point. Yeah, an x and a y value. So that's actually on the next page called a solution, particular solution to the differential equation. So this is the same guy. Go ahead and point over here because we already did him on the previous page, and we're going to write what we got. We got y equals c e to the x squared over 2. We separated, we integrated, and we've got that. This one, though, we need to make sure that ours goes through 0, 5. So when you put in a 0 for x, right there, a 5 has to come out for y. So you're going to solve that. I indent when I solve for Carl. I say c e to the 0. You're just plugging it in. So who's our constant in this one? 5, right? Our constant's going to be 5, because what's e to the 0? 1. All right, awesome. So let's go write that down. Here is our solution, 5e to the x squared over 2. This guy right here is called the particular solution. That was the first one. It should have been a little rough. Some of you are already nodding, right? If I were to go graph that, when I put in a 0, a 5 comes out. So it's 1, 2, 3, 4, 5. If you were to graph it on your graphing calculator, it looks kind of almost like a parabola, but it's got a little bit more of a flat bottom. It's that one, right? And how do you think I get the slope at 1? Go back and look through the whole problem. What's the slope right here at 1, according to the problem? What does it say the slope is, or the derivative is? X times what? Y. Yeah, I just multiply the x. That's what it's saying, is you're giving the curve whose derivative is. So you're actually going backwards. So here's something that's important, and I'll show it to you working on the next page. That constant c, you get a little leeway with when you find it. All right, you can find it any time after you take a derivative. So tomorrow you'll be in groups. It might get a little frustrating because Devin might always find it right away. You might wait till the end. You might find it in the middle. But if you all just keep working, you'll get the same answer. And I'm going to show you that happening on our first one that we actually, that one should have been a little rough. Was a little rough? You're like, what's going on here? It's a totally new topic. But I got you. I always make sure we get there in the end, right? So let's go back, and we're going to start. This one's much more complicated, but the process won't change. What's the first thing? First of all, when it says to find the particular solution, I am going to be finding y equals, that top variable, okay? So when I'm done, I want y equals. Will this have a c in it, or will I be solving for C based on the stem of the problem? Will it have a C in my answer, or will I be finding it? What do you think? I'm going to be finding it. How do you know that, Rach? They give me a point. They're going to lock me in on a specific particular curve. If they didn't give me a point, it would have said find the general solution, and I'd have all these graphs. All right, first thing I do is separate. Who needs to move over onto the left? The e to the y. I don't just move it over, right? I have to mathematically get it over there. How do I do that? Just divide by it. Yeah, so do 1 over e to the y. And this is my function of y, dy, equals, keep all the x stuff over here, and then dx. So that's the first thing. That's called a separated differential equation. Are we good on separate? The second one usually makes it click about 50% better. Do you get what I mean by separating? Yes. All right, what's the second thing I do? I need to figure out what y is, which means I need to undo the fact that I've got derivatives in here. I integrate both sides. Yep. So I'm going to integrate the left, and I'm going to show all the work just until I'm comfortable that most of you are getting it. I'm going to integrate the right. Today, the integration won't be hard. And actually, it won't ever get super hard. There's like 1 or 2 throughout the chapter where you might have to do a little U sub or something, but for the most part, they'll be pretty straightforward. On the right-hand side, it's a no-brainer because it's power rule. So you guys go integrate the right-hand side. Go ahead, Caden, what's the right-hand side? No, you took a derivative. It's very common, so I won't judge. X cubed. Perfect. And then check yours. Take your derivative, you're right back. The constant goes on the right-hand side. So the second step is something you already know how to do, but be careful. This is not natural log e to the y. Okay? It's not. It's the integral of e to the negative y dy. How do we integrate e to the u? That's the question. What is that? What do you think? What's the antiderivative of e to the negative y? Negative e to the negative y. Yeah, it's actually u sub with u equaling negative y, but then when we take the derivative, we get a negative. All right, why no constant on the left? Just I'm going, make sure you get every step done. I'm putting it into the one on the right. Constants plus constants times constants to the power of constants are still what? Constants. So you can just call it one time in your problem. Now, I'm on the y attack. Don't lose track of what you're trying to find. I want to figure out what y is, so I'm going to go point at that. I can't natural log yet. That's a common mistake. You need to get e completely naked, nothing in front of it, nothing underneath it, before you can natural log it. So you need to get that negative moved over onto this side. Now, why do you think I just left it plus c? It's still just a what? Constant. Now, suppose Alejandro remembers me saying, so point over here. Do you remember how I said you can find c any time after you integrate? And maybe he says to himself, I'm just always going to find it right away and be done with it, right? So just a sec. If you decide to find it right here, so I'm going to draw a little bar here, and we're going to pretend that tomorrow in his group, he goes and finds it right. Yes, did I make a mistake? Oh, thank you. There. Yes. Thank you, all of you. All right, are you ready? So we're going to be all here. Are you ready? He's going to go here and go find C right now. So he's going to go back up, put a 1 in for X and a 0 in for Y. All right, so let's go do that. When I put in a 0 in for Y, I'll have negative e to the 0. Go ahead and write it down. Equals, and what are you going to put in for X? 1, right? So it'll be a 1 cubed minus 3 times 1 squared plus c. So let's pretend we're him for a second, and he's on the I'm going to always find it right away train. You will. You'll decide. I do it. I've made a zillion keys, so I actually like to get rid of negatives and fractions. So I probably wouldn't have found it yet, but that's okay. So on this side, I get a negative 1. equals -2 plus C. So if you did it over here, Alejandro, what's your C? 1. Now, the minute you find it, though, you have to put it in. All right, Calvin? So the minute he finds it, he has to go put it back into that red one because that's where he found it. So here's his workflow. He's got a negative e to the negative y equals x cubed minus 3x squared, and his is a plus 1. Agreed? You ready? Why did I put a plus 1 in? Right here. Because he found it right here, and it was a positive 1. Agreed? So, Alejandro, if you did this course, how would you get rid of this negative? Multiply by negative. I'm not going to finish his side over here, but I want you to see what he gets. All right? So this is what he has, and he's going to keep working. All right? Now, Lodemeyer says, I'm going to multiply everything through by a -1 to get rid of the negative. But maybe he decides to find it right now. Are you ready? He'll say e to the 0 equals -1 plus 3 plus c. Right, Luke? So you've got 1 equals -1 plus 3 plus c. What's your c? -1. His c is -1, but he found it in a different spot. I want you to observe what I just said. I said his c is -1, but he found it in a different spot. So look at where they're sitting. If they're in the same group tomorrow, Alejandro's sitting there with this to solve. Correct? Are you with me? And Lodemeyer sitting there with his to solve. What do you notice about them? They're the same. So you can find C maybe Rachel says, you know what, I'm just going to wait till I'm all done and find the C. It'll work itself out. So let's go finish it off with Lucas's flow here. How do you undo E? Natural log, both sides. So we'll do natural log e to the -y equals natural log of all this stuff. That's what this workflow would have done as well. So it's not going to change that. Okay, and then I get a -y equals. So it becomes easy once you get used to it. Actually, kids in BC kind of like separation of variables. So once I'm done here, what do I do to get rid of the negative? What do I do to get rid of the negative? I multiply it over. So I have y equals negative natural log negative x cubed. It's a long process, but this is called solving a differential equation. All right? When do you find C? Whenever you want, after you integrated. I'm going to tell you I like to get rid of negatives and fractions before I deal with it. All right, so let's go down here. Key terms. Do you know this stuff? A differential equation is something changing, usually over time for the real world. When you solve it, you're looking for, well, what's the bacteria at a given time? The word problems are actually really interesting this chapter. Separable differential equations, you can write it as a product. We integrate. We've got Carl, and then most importantly, what's the difference between these two words? The general solution has what in the answer? C. The particular one locks you into a particular solution. So let's try one more. Let's see if you got it down. Just practicing today. Are you ready? What's the first thing I'm going to do to solve this? Separate. What am I solving it for? Y. There. Go separate it. If you don't separate, you can't solve. It's actually not a very difficult process once you get the flow of it. To be absent is kind of a doozy. You'd never figure it out on your own, put it that way. So stop after you've separated, and I want to discuss the use of the 3. Are you ready? So I want to keep dy over here. If it were me, I would just move the y squared over. How many of you moved the 3 over with it? You'll be just fine. But remember, you're on the y attack. So what are you going to have to do eventually anyway? Divide by 3. So you're just sort of full circled with the 3. It doesn't matter because the constants wash out. So, I mean, if you wrote a 3 here, you're going to divide by 3 anyway. So it doesn't affect stuff. But let's get it out. I like to keep all constants on the right. All right. Once I've separated, see if you have the flow down. What do? Integrate. They won't be hard today. All right, so we're going to integrate both sides. I like to bring constants out front of my integrals. Are you starting to see it? You look a little less confused. Savannah, what's the antiderivative on the left? Y cubed over 3, technically plus Carl, but what did we all agree we're going to do? We're going to leave Carl till the end and put him on the right-hand side. On this side, constants stay out front. It's actually kind of a leisurely process. It's just a long process, right, Connor? So what's the antiderivative of x? X squared over 2. Yep. So I'm going to have an x squared over 2, and then how about the antiderivative of sine? Negative. Now I'm hearing you guys. It's an impressive process to see on paper. Like if your friends in pre-calc look at your work, they're going, what are you doing? But it actually has such a flow to it. So what's wrong with mine right now? No, Carl. Now, you could solve for Carl right now, but be in my brain. This isn't one where I'd solve for Carl right now. What don't I like? I don't like fractions and I don't like negatives. So I'm just going to let him wait until I feel a little more comfortable. But if you found it right now, yours will be a third of what it should be. Oh, we won't on this one. But if I had to, I want to make a point where if there was one given, watch this. Suppose Rachel solves for it right now. Don't write this in your notes. Are you ready? And there was a point given and she got C being 2. What's she going to have to do with that C? Multiply by 3. And if you waited, you would have a 6. Her 2 will turn into 1. So it just depends on when you find it. Right now, though, this wasn't a specific solution, so you're right, Rachel. I'm going to triple both sides. It'll wipe out the 3, x squared over 2 minus cosine x. Why am I not putting plus 3c? It's still a constant, and it'll work itself out. You don't have to do that with the constant unless you found it. If I found it, then I have to triple it. All right? I'm almost done. What do I do to both sides? Cubed root. All right, I want to do one more with you. Nothing's due tomorrow, so don't just hang with me through one more example here. This next one, what did I do? I'm starting to mess with you a little bit. I changed the independent variable on purpose because when they go word problems, it's going to be stuff changing over time. So when I solve this, it's really important for you to understand what are you solving for? X as a function of t. Exactly. So when I'm done with this problem, I want to be able to say x, whatever, maybe x is the coronavirus, I don't know. But there's some x that's being determined by t. What's t always going to stand for? Time. So the first thing I'm going to do is get my x's and my t's separated. So I'm going to go over here, and I want to keep the x and the dx, because I like to keep what I'm solving for on the left. On the other side, how do I move this guy over? I divide. What happens when you divide by e to the negative t? It becomes e to the t. Yeah, you guys have been really good dealing with exponents. So this becomes e to the t dt. I'm feeling better now. We're responding. Do you notice how I keep doing it examples until you respond, though? I just got to get a vibe, and then I'll quit. All right, what do I do next? Integrate. Let's go do it. They won't be hard to integrate usually. You have a quiz on Friday. I think one of them's hard to integrate. The rest are kind of like antiderivative of secant squared. Tangent. Antiderivative of x. What is it? X squared over 2. You shouldn't struggle integrating because that's not what I'm trying to teach you right now. What's the antiderivative of e to the t? E to the t. Don't forget Carl. Could you find him now? Yes. And I want to make a point because I think this might not be sticking with some of you. Suppose Fromm is like, Carl makes me nervous. I don't know what to do with him. He should find him right now and have him keep morphing with his math and just let the nerves settle. All right? So if he finds Carl right now, watch what he'll do. He'll put a 0 in for t and a 1 in for x. Watch what he'll get. 1/2. Are you watching? Right? The x is 1, t is going in, is equal to e to the 0, which is 1, plus c. What's his c right now? Negative 1/2. What does he have to do with it right now? Plug it in. If he found it now, it's going in now. So he's going to write x squared over 2, I think we're getting it, equals e to the t minus a half. But what will he have to do at this point? What's he get? Multiply everything through by 2, correct? And he's going to say x squared equals 2e to the t minus 1. But Kellen's like, I don't like fractions either. So he gets rid of it right here, the fraction. He's like, Carl, you're going to wait because I hate fractions. I hate fractions, I hate negatives. So I personally wait till the end or at least get rid of fractions and negatives. Yes. Right here, 1/2 minus 1. So over here, Kellen's like, no, not finding it yet. He's going to double and say x squared equals 2e to the t plus, why am I just putting a c there? Because it's just a constant and more, yeah, that's exactly, it doesn't need to be. So now watch what happens if he says, I'm going to take it all the way to the end. He'll say x is equal to the square root of 2e to the t plus c. He still hasn't found it yet. Sometimes you're going to get in a flow and you're going to be like, I'm going to wait till the end. There's something you need to consider here, plus or minus. Guess what our c is going to end up being? -1. Yes. Okay, Fromm's was a -1/2, but he found it earlier and had to double it. Does that make sense? So Kellen's sitting there going, well, I'm going to find it now. So what does x have to be? A 1, right? When you do the square root of 2e to the 0 plus c. Settle that in your head. What's his c? What's his c? -1. Yep, you can see it. This is 1, right? 1 has to, he'll get the exact same answer. Now wait one last second before I stop you. Are you ready? When we do the plus or minus, so I'm going to finish off Fromm's over here as well. And again, the reason they're taking so long is because I'm doing them all 2 ways. But it's exhausting. But I want you to see that it doesn't matter. When do you find C? Whenever the hell you feel like it, as long as you've integrated, correct? You could have done it anywhere from here on down. It will be different though, right? So I got the exact same answer, the exact same answer. The last thing is important, so don't tune out. How do I know if it's the plus or the minus? Because when you take roots, you have to do plus or minus. The answer to it is you go back to the initial condition. The point given, did it spit out positives or negatives? X of 0 spat out a what? +1. If that had been x of 0 equals -1, I'd choose the negative root. So it does need to be considered, and sometimes it is actually negative. So that is your boom. What's this called that I just found encircled? A particular solution to a differential equation. Well, not due tomorrow. This is actually due next Wednesday at the earliest. You don't have a, yeah, I wouldn't do that. You could though. I'll tell you the reason why I'm, whoops, pause this.